Mass timber has emerged as a sustainable alternative to traditional construction materials like steel and concrete, primarily due to its lower carbon footprint and renewable nature. However, its sustainability is complicated by various end-of-life challenges and limitations that must be addressed to maximize its environmental benefits. One of the significant barriers to the sustainability of mass timber is its reusability. Most mass timber elements are unique, making it challenging to reuse them. On top of this, the supply of old mass timber elements is very limited, since it's a relatively new building material. Many buildings have not yet reached the end of their life cycle, where disassembly and deconstruction becomes necessary. As a result, the potential of reusing these elements is currently largely untapped. The manufacturing process of mass timber often involves adhesives and can even involve chemical treatments that pose risks at the end of the element's lifespans. When mass timber products are incinerated, harmful chemicals can be released into the atmosphere. Additionally, nails or screws that are used in construction can complicate the disassembly of the elements and may require cutting through some parts of the elements. This process doesn't just generate a lot of waste wood, but it also increases the risk of damaging the elements during disassembly. Assessing the remaining structural capacity of the used elements is also a challenge. Thorough inspections and non-destructive testing are essential to identify hidden defects, which can be time-consuming and costly. The DFD, or Design for Disassembly concept, is still relatively new and underutilized in mass timber construction. Many architects lack experience in designing buildings that can be disassembled, and many builders lack the experience of actually disassembling the mass timber buildings. This leads to inefficient practices that hinder recycling efforts. This is mostly because, as we mentioned before, the mass timber construction sector is still relatively new and people haven't had the chance to work with it yet. And even if people have had the chance to work with mass timber, the buildings haven't yet reached the end of their useful life, which means that they aren't being disassembled and deconstructed yet. Large-scale recycling initiatives for mass timber have not yet been widely implemented, further limiting opportunities for sustainable end-of-life management. From an economic perspective, reusing mass timber elements often proves more expensive than just using new virgin materials. Designing with reclaimed components can be difficult because of the compatibility issues between the old and the new elements. Furthermore, reclaimed components may suffer from defects or contaminations which further complicate their reuse. Proper material selection and documentation are crucial for enhancing the end-of-life possibilities. Establishing guidelines for the disassembly of mass timber buildings can facilitate better practices in design for disassembly. This includes creating a system that promotes reusing old mass timber elements while ensuring that they meet safety and performance standards. While mass timber holds promise as a sustainable building material, significant challenges remain regarding its end-of-life management. To fully realize its potential benefits, stakeholders across the construction industry must invest in developing practices that enhance reusability, address contamination risks, and improve economic feasibility. By prioritizing design for disassembly and establishing comprehensive guidelines, the industry can move towards a more circular economy that maximizes the environmental benefits of mass timber while minimizing waste. Just like the mind map with all of the benefits of mass timber, we now also have a mind map with the challenges and limitations of mass timber. Go over to the TimberTalk Patreon page to become a member and download the mind map for free.
Stay informed, stay inspired. TimberTalk.